I'm Hiren Chandiramani. I'm a go-to-market specialist on S3. Been with Amazon about 2 years. Bunch of on-prem companies before that. Made the jump to cloud 2 years ago. Okay, let's dive into it real quick. When we shipped S3 back in 2006, 16 years ago, it was known as the first cloud storage. It was used for backup. It was used for maybe websites, but today it's a very different story, right? We see a majority of our deployments in very, very active workloads. There's a lot of data lakes on there. There is machine learning models being trained using data on S3. AD is one good example. We see financials doing back testing of their new quant models using data stored on S3, IoT, and of course, there is still a lot of content delivery being done and user-generated content, media archives, all of those are on S3. And the reason why it's been so successful is because of the ability to scale out, right? Today, S3 has exabytes of data with over 200 trillion objects in there. These stats may be updated at reInvent. These are from, I think, last year or earlier this year. And we even have 100 million requests per second, right? And I think we top out at 60 TBPS per region, okay? So the scale of S3 is huge, but along with that scale comes leading durability, availability, and resiliency. So 11 nines of durability. And most of our storage classes, which I'm going to talk about very shortly, are regional storage classes. That means they're deployed in all the availability zones in a region. So as you know, we have about 27 regions. I think we have announced a bunch more that are coming up this year and next year. Each region is a geographically separated location, separated by hundreds of miles, mostly. And within each region, you have multiple availability zones, 3 or more most of the time, right, for that. And each availability zone is separated again by a significant distance, anywhere from 10 to 60 miles. I think we top out at 60 miles because you want to make sure you don't run into too much latency right there, right? So each availability zone is 10 to 60 miles, and each availability zone has its own power, redundant power, cooling, network, right? And consists of more than one data center potentially. And so highly resilient, highly available. We can, for our regional storage classes in S3, you can handle an entire availability zone being gone, right? And you have no effect on availability or durability for that matter. So when you actually do store data in S3, we store the data redundantly in all availability zone. There is an exception for one zone storage class, which I'll talk about, but otherwise it's stored redundantly in the availability zones. And one thing I do want to point out is back in 2020, S3 became strongly consistent. S3 was always known to be eventually consistent. And in 2020, we announced it was kind of a quiet rollout, right? It just happened under the covers. Many people were like, really? You guys did that? It was a multi-year effort that S3 went from being an eventually consistent system to a strongly consistent system. So right now you get strong read after write consistency, strong list. And this was very important for some of the use cases that I talked about, data lakes, analytics, et cetera, right? That you wanted that strong consistency for those use cases, okay? All right, S3 has, as I said, launched in 2016. Important to point out that since 2006 to 2021, we have done about 15 or so, don't quote me on this, around 15 price cuts, right? And we have constantly lowered the price across storage costs, across API costs, right? At the same time, we do understand that we can't continuously keep going lower and lower and lower. We can, but there is a limit. But we have also innovated on the storage classes on the other side. So you can see on the right-hand side here, back in 2006 was S3 standard, and then we have constantly innovated after that with S3IA, intelligent tiering, which is one of our most popular storage classes right now that were launched in 2018. And most recently, a Glacier Instant Retrieval, which is a long-term archival storage class with millisecond access and the same performance as S3 standard in 2021, reInvent 2021. So you'll see us continue to innovate there, on the right side, right? As we continue to
And the reduction in cost is for S3 standard from 2006 versus S3 standard today, or
it
S3
is
standard 2006 versus, intelligent glacier tiering,
yes on all of the above, right? This particular chart shows really standard, right? Because it was, I think, $15 a gig back then, and now it's like 2.1 cents per gig per month. But over time, we have cut prices across every storage class.
And then storage prices include the API costs as well as the resident storage.
There are different components of the cost, and I'll talk about that right as we go through this. So real quick, this is a snapshot of the storage classes I'm going to talk about. If you notice back here, there were a bunch of them, which I'm not going to talk about today. There is real quick standard, one zone IA, which is our only zonal storage class. You store the data in one zone. We position that for data that can be easily replicated. Keep in mind, you're not giving up on durability or availability with one zone, right? It's just that you cannot take the outage of an entire zone like you can with the regional storage classes. And I won't be talking about outposts, right? But as a quick snapshot, I'll be talking about these 5 storage classes, and they each are meant for different access patterns. So it's very important when you're thinking about storage classes to think about how you optimize your cost using these storage classes. And in order to do that, you have to think about what is your access pattern, right? Is it predictable or changing? When you talk about predictable access patterns, we are referring to data where the retrieval rate goes down as the data ages, right? I think we have all come across these examples. Photo sharing, you upload a bunch of photographs to your favorite photo sharing website, your friends and family look at it for the first week or 2 weeks, and then it falls off a cliff, the access. Medical imaging is another great example of that, right? You break a bone, you have an x-ray, you're being treated for it, accessed frequently, and then the data has to be kept for the life of the patient. So access falls off again, right, for that time. So there are a bunch of these use cases that you have where data access drops off over time as the data ages. And we call that predictable and known, right? So if you have those, the best way to think about optimizing is using our standard infrequent access, instant retrieval, flexible retrieval, and GDA, Glacier Deep Archive. Let me go through each one of those real quick. All right, so for standard, this is for frequently accessed data. What we mean by here is that data which is accessed all the time, multiple times a month. Okay, so data which is very, very active. So you want to ingest your active data first into S3 standard. There is obviously put costs, get costs, but there's no charge for retrieval. There's no minimum amount of time you need to store the data in S3 standard, right? As the data ages and you have less frequently accessed data, you want to think about S3 infrequent access, right? Again, this has millisecond access to the data, very similar to S3 standard in terms of performance and throughput and everything, except now you do pay a little higher cost for puts and gets, and you do have a retrieval charge. There's a 30-day minimum to store the data in S3 IA, but the cost to store data is lower. So if I look at S3 standard, public pricing is 2.1 cents per gig. With S3 IA, it drops down to 1.25 cents per gig, right? So for less frequent access, but you're paying more for puts and gets out there. And you have a retrieval charge with a 30-day minimum. US East, thank you. I'm quoting US East prices here, always. Depending on the region, the prices may change.
I have to pick that region.
Yeah. All right. Christian picked it. No, I'm kidding. All right. The next one is S3 Glacier Instant Retrieval. The mental model here for GIR, for short, is that you want to pick that for data that's accessed about once a quarter, maybe 3 to 4 times a year, right? Again, you pay a little higher cost for puts gets. There is a retrieval charge and a minimum duration of 90 days of storage. But the price drops a lot. It goes down from 2.1 to 1.25 to 0.4 of a cent now, right? So literally 1/3 the cost of IA, 1/5 the cost of standard, right? These three storage classes are what we call our synchronous millisecond access storage classes. You do a get, you get the data back in milliseconds, right, as you would expect. The next two ones are Glacier Flexible Retrieval and Glacier Deep Archive. These are really our async access storage classes. In order to retrieve data from these storage classes, you first have to restore a temp copy and then do a get, right? And the restoration of the data will take minutes to hours for GFR. You have three options. You have bulk, you have standard, and you have expedited. Expedited is 3 to 5 minutes, costs more. Standard is 3 to 5 hours, costs a little bit less. And then bulk is free. We made that change back at this last reInvent, 2021. So for Glacier Flexible Retrieval, if you happen to choose the bulk retrieval option, it is free to download all the data there. There's no retrieval charge. You do pay for the API calls, though.
And egress, too.
Sorry?
And egress.
And egress, too. Yes, absolutely. And then finally, you have GDA. GDA is meant for long-term retrieval, long-term archival of data. When you think about GFR, we would say it's for data that's retrieved maybe about once a year, maybe max twice, right? GDA is for data that's retrieved less than once a year, right? You don't want to keep frequently data which is more frequently accessed than that. You have a question?
It's worth asking. You're probably not going to answer it. But what storage media is Glacier and Glacier Deep Archive?
Like you said, I can't answer that.
It's stored by,
Punch cards.
There you go.
No, not punch card.
elves.
The deep archive and things of that nature where you're keeping data for more than years at a whack. I mean, are you doing some sort of constant monitoring of the data to see if there's any bit loss or data loss, or you lost some drive out in Tanzania or something like that?
Yeah, so
Data that
it's just not for GDA. It's across all storage classes. We are constantly monitoring for bit rot, and you're constantly repairing anything that needs to be done, right? That's how we achieve our 11 nines of durability with that, right? It's across all storage classes, just not GDA.
So if one were to ask, how long can you keep data in Glacier Deep Archive? Are we talking 2 years, 25 years, 50 years,
We've
100
had,
years?
2006.
They'll say forever.
So
I mean, we haven't reached that limit yet. I mean, people have data from the point it launched till today. So
do you have documented access points of people actually went from 2006, uploaded to S3, and they're like, hey, we need this file from 2006 the day we uploaded it. There
Deep
are
Archive
people
has been around.
doing
no, Deep Archive hasn't been along since 2006. Standard has been around,
Right.
And certainly we have that examples, but I will get you examples if you want offline. I don't have them handy of people who have.
Would you say, in a general sense, your opinion of the statement "tape is dead"? Would you agree or not with that?
I am not going to make.
It's a general comment. I'm just asking you about a general industry statement.
No, there is a lot of tape out there. Customers do love their tape, and they're holding on to it. So no, it's not right now. But certainly, we at the same time, we do have a lot of customers who are looking to not do that undifferentiated heavy lifting of managing their own tape, and they're thinking about GDA as a good alternative there.
You almost got me there. Okay.
What's that?
It was a trap question. I'll admit it.
I know. Well, yeah, it's been declared dead, yeah, forever, right?
I was trying to find out if it was specifically alive there. That's all.
All right, so I tap danced.
I know.
Yeah.
Quite good. Quite good.
Yeah.
Very good.
Okay. So selecting the right storage class really comes down to three things, right? Frequency of access, duration of storage, and retrieval time, right? So with the frequency of access, I talked about how S3 standard is for data which is accessed multiple times a month, all the way down to GDA, which is less than once a year. Duration of storage, depending on your storage class, you have some minimum duration, so you want to take that into consideration. And then, of course, your retrieval times, because, for example, for 4 of our storage classes, it's millisecond access. 3 of them, which I talked about, standard IA and GIR. But for GFR and GDA, they are minutes to hours, depending on your restore options out there. Okay. Now, once you have figured that out, you have your access pattern in mind, you know it is predictable, and you know how it ages, The way you would take advantage of the storage classes is by using our lifecycle policies. So for example, going back to the photo sharing example I gave before, you may want to say that, when I upload photographs, I know my users download them constantly for the first 30 days because they're sharing them with friends and family. The data goes into S3 standard, but I know it drops off the cliff after that. So I'm going to put a lifecycle policy that says after 30 days, put it into Glacier Instant Retrieval. So you don't have to go down each and every storage class. You can go directly from standard into GIR, for example, and then after 365 days, you can put it into GDA, right? So you can automate that through our lifecycle policies. As a best practice, we also recommend if you don't want to keep the data around forever, then you put an expiration policy at the end of it. So the lifecycle also allows for expiration policies. In this example, you could say after 7 years, delete the data, for example, out here. Okay, let's talk about data with unknown access pattern. And this is the interesting one, right? Data with unknown or changing access patterns. You're talking about machine learning workload. They're talking about data lakes, which have many shared work sets, which are used by different groups. You're looking at, again, maybe backtesting of new AI/ML models. Whatever it is, the data tends to become hot, cold. It doesn't age predictably with the age of the data. In that case, we have something called S3 Intelligent Tiering. We had shipped this in 2018. It's one of our most popular storage classes. It is the only cloud storage class today that automates your cost savings by moving objects between different tiers of storage automatically based on the access pattern of the data. That's a big difference between lifecycle and intelligent tiering. With lifecycle, you're moving it based on the age of the data. It's a one-way movement down, right? You're moving it from standard to S3IA down to GIR potentially, and you don't promote on access with lifecycle. With intelligent tiering, and I'll talk about this, the object moves depending on the access pattern, right? There is no data cost for moving the data between the different tiers within intelligent tiering, and there is a small monitoring fee. The monitoring fee depends on the number of objects that you have, okay? So intelligent tiering has 5 different storage classes or storage tiers. I want to make sure that I use the right word, storage tiers behind it. The frequent access tier corresponds to S3 standard in price. Infrequent access tier corresponds to SIA in price. Archive instant access to GIR, and these two to GFR and GDA respectively. The first 3 tiers are always on and automatic. You can't change anything there, right? The last 2 tiers, because they're async tiers, right? You got to do a restore before you can access the data, are opt-in. You got to turn them on if you want, right? When you ingest data into intelligent tiering at the beginning, it goes into the frequent access tier. It'll stay there until it's not been accessed for 30 days. If it hasn't been accessed for 30 days, it drops down to the infrequent access tier. It'll stay there for another 60 days of no access before it goes down to GIR. To the archive instant access tier, right? And then depending on how you configure the opt-in tiers, it'll go down to those tiers. Assuming that you did opt into it, these 2 tiers are a little bit more configurable. Minimum number of days before it goes down to archive access is 90 days. And for deep archive access is 180. You can configure that to be anywhere between 90 to 2 years for archive access and 180 to 2 years for deep archive access tiers. On access, the data will move back to the frequent access tier, okay?
Until the scanner repicks it up again.
Until it's not been accessed for 30 days again,
Okay.
and then it moves down, right? So it has to be not been, it'll be there until 30 days, 60 days of no access.
Yeah. Is that just part of your storage class on every single tier, or is this something you have to opt into?
This is a storage class by itself. S3 Intelligent Tiering is a storage class with tiers behind it, right? When you do a put, you can specify and say put into Intelligent Tiering. By default, everything goes into, if you don't specify anything, it goes into S3 standard, right? But on a put, you can choose to say put directly into Intelligent Tiering, or you could even put directly into Glacier. for example, Glacier Deep Archive, if you wish, right? But by default, if you don't specify, it goes into standard.
Okay.
A lot of our customers are now using intelligent tiering because it automates everything. It takes away the thinking. Yeah.
So if somebody wanted to game this, they could actually go in and access all their data over time and keep bringing stuff all into
Into standard, but you're paying more then, right? Because as I mentioned, that these tiers provide you automated savings as the data moves down. So this is corresponding to S3 standard. You're paying 2.1 cents US East pricing.
So regardless of how much data that they are accessing, it's going to be in standard tier. They're paying for that capacity
And if it
during
goes-
that interval while it stays there for 30 days before it moves to the next tier.
Correct, and then move to the next tier, at which point the price will drop and it moves down to the next
I
tier.
thought a flat fee for this.
Yeah,
No.
so it'll just go down. Now, we did a study and we estimated, and this is a stat from reInvent 2021. We estimated we have saved customers $250 million just by this. In fact, we announced this tier, the Archive Instant Access tier, along with when we launched GIR in reInvent 2021. We launched it on November 30th, I believe, 2021. December 1st, a bunch of the customers saw the data flowing down there. And the December bill came down, right away, instantly. And all these three storage classes provide you with the same performance, right? Millisecond access, throughput, et cetera. So we've estimated we have saved customers $250 million. You're going to see an updated stat coming out at reInvent again.
What's the time on that? 1 year?
For which
For
one?
this 250 million over?
I think over the life of intelligent tiering.
Okay.